Welcome to myprojectbazaar.com. Project title is Weighted Data Gravitation Classification for Standard and Imbalanced Data. Let's see the abstract. Gravitation is a fundamental interaction whose concept and effects applied to data classification become a novel data classification technique. The simple principle of data gravitation classification is to classify data samples by comparing the gravitation between different classes. However, the calculation of gravitation is not a trivial problem due to the different relevance of data attributes for distance computation, the presence of noisy or irrelevant attributes, and the class imbalance problem. This paper presents a gravitational based classification algorithm which improves previous gravitation models and overcomes some of their issues. The proposed algorithm, called DGC+, employs a matrix of weights to describe the importance of each attribute in the classification of each class, which is used to weight the distance between two samples. It improves the classification performance by considering both global and local data information, especially in decision boundaries. The weights were optimized by means of CMA-ES algorithm, which showed to perform an effective learning rate of optimal weights for the different attributes and classes, ignoring noisy attributes and enhancing relevant ones. The effects of gravitational around the instance allowed an accurate classification considering both local and global data information, providing smooth classification and good generalization. The CMA-ES separately controls change rates for the mean value of the distribution, M, the convergence matrix C, and the step size. The change rate from the mean value M given a fixed sample distribution is determined by the parent number and the recommendation weights. The larger E, the smaller is the possible change rate of M. Similar holds for most evolutionary algorithms. Its advantages is highly accuracy for both global and local data. DGC plus is accurate and smoother border classification. It is cost sensitive. Let's see the data flow diagram of the project. Here we have taken two datasets. What is meant by dataset? A dataset is a collection of data. Most commonly, a dataset corresponds to the content of a single database table. We implemented two different types of standard data. Standard dataset will be extracted and stored in a database. In pre-processing techniques, pre-processing technique will be made after data storage to omit or remove the missing values in data. For pre-processing method, k-means clustering algorithm will be implemented. Two main principles for the adaptation of parameters of the search distribution are exploited in the CMA-ES algorithm. Here we are using two datasets. One is a hard dataset and another one is a long dataset. We have implemented cluster algorithm in both datasets. Taking the attributes, and for each attributes we have taken maximum and the minimum value and find out the threshold value. Comparing the two datasets, we have fixed the threshold value. In final result, it will omit the number of attributes which is beyond the threshold values. Welcome to see the project. Click Browse button and select the dataset. I am choosing the hard dataset. Click Open button. The file reads successfully. This is the dataset values. Click Next button. Now load the same dataset. The data loaded successfully. Now you have to extract the file. Click Extracted button. Record inserted successfully. How to view the data? Click View button. The data are fetched in the database. Click Next button. In hard dataset, you can see the missing values in some of the attributes. To omit this, go to Omit button. The data cleanup succeed. Now the null values are removed. Now For finding the threshold value, we have to calculate the maximum and minimum values of the each attributes. Click onto the maximum button. You will get the maximum values of the attributes. Press get button. You will get the overall maximum value for the attributes. Likewise, you have to click minimum button to get the minimum values for each attributes. To get the overall minimum value, go to get button. You will get the overall minimum value. In hard dataset, the maximum value is 866.2 and the minimum value is 363. Press get button to get the threshold value of the dataset. Now go to next button. Now you have to browse the lung dataset. File read successfully. This is your lung dataset attributes and the values. Go to next button. Load the same lung dataset and extract the datas. Click view button to see the dataset values. Go to next button. Here also we have to calculate the threshold value. For that we have to find the maximum and the minimum values for each attributes. To get the overall maximum value of the lung dataset, press this one. You will get the maximum values. To get the overall minimum value, click this one. You will get the minimum value. To find the threshold value, get the maximum and the minimum value. For lung dataset also, the maximum value is 864.2 and the minimum value is 364. To get the threshold value, get this one. You can see the threshold value for lung dataset. Comparison graph will be displayed for both different data sets. Go to next button. Click hard classification method. The classification process is working. Click lung classification. In lung dataset, the classification process is applied. To group a classes, go to classes button. Among the 14 attributes in the dataset, only 3 attributes has to be classified. Press classes form. Class A represent high risk class, class B represent the low risk class. Press this one. Among the 14 attributes, the high risk attributes are displayed here. Among the 14 attributes, the low risk values are displayed here. To know the lung high risk and low risk classification, press here. Press this one. You will get the high risk classes and the low risk classes. Go to next button. Click this one. First shows our method is 90% accuracy from the existing. Thank you.